by dissecting extremely small glimmers of light coming from a period of time very near to the beginning of the universe's history. The James Webb Space Telescope was able to find what is perhaps the universe's oldest known black hole and what is in it. The lightning-fast formation of black holes across our very young cosmos continues to be a puzzling enigma. Astronomers are still looking for even younger black holes, which are referred to as primordial black holes, and which are thought to have come into existence very shortly after the Big Bang, or according to some ideas, even before the Big Bang. However, they have not been able to locate them as of yet. The most widely accepted explanations for the rapid proliferation of black holes in the universe after the Big Bang are either that they are the remnants of enormous stars that formed at a much faster rate than the ones we know today, or that billowing clouds of extremely dense gas suddenly collapsed to form the all-consuming singularities in spacetime. Interestingly, James Webb Telescope finally sees what's inside a black hole. Both of these hypotheses have their proponents. The direct collapse method would need to start with a larger amount of matter in the galaxy directly collapsing into a black hole, said Larson. This would have to be the starting point. It's less likely, but it would take less time, and there hasn't been that much time at the point where we observed it, you say. But it would still take less time. It is more likely that it is a so-called population 3 star, which is a category of hypothesized stars that were the first to ever exist in the universe and were made of just hydrogen and helium. This star is thought to have exploded and left behind a black hole approximately 200 million years after the Big Bang. The black hole then accreted a lot of material pretty quickly and occasionally at a faster than stable rate to swell up to the size that researchers observed. The researchers will now begin working alongside the team that constructed MIRI in order to seek for a signature of the light from distant galaxies that is much stronger. These emissions could provide more information that can help us figure out how the strange black hole at the heart of our galaxy came to be. Inside of a black hole is thought to be something known as a singularity, at least according to the hypothesis. In a black hole, all of the stuff is eventually squashed into something called a singularity. It is true that classical physics informs us that there is a point of infinite density at the core of the black hole. But the singularity is also where classical physics breaks down, so we shouldn't believe what it says here. Some people talk about it as a point of infinite density at the heart of the black hole, but it is probably erroneous. If certain mathematical conditions are met, the singularity at the center of a spinning black hole transforms into a ring rather than a point. However, that particular mathematical scenario won't ever occur in the actual world. Some people believe that the singularity is a complete surface that exists inside the event horizon, whereas others disagree. Simply put, we have no idea. It's possible that singularities don't even occur in genuine black holes since they're just not there. Massive amounts of matter have amassed in a single location, and then this stuff has been packed together as densely as it possibly can be. This is done to the point that the gravitational pull from the accumulation is so powerful that not even light can escape it. Black holes are the result of this process. If you were to approach a black hole with your feet first, the pull of gravity at your feet would be far higher than the draw of gravity at your head, and as a result, you would get stretched out like spaghetti. This is because the gravity around a black hole grows so rapidly. The process is officially referred to as spaghettification, which is possibly the greatest example of jargon the scientific community has to offer. While the stuff that is contained within the event horizon is being compressed into an area known as the singularity, which is an area of space that is infinitesimally small. The size of a black hole is often measured by the region of space from which we no longer receive any light. It is the point in space away from the singularity at which you would have to be moving at a speed greater than the speed of light in order to escape the gravitational pull of the black hole. If you pass over the event horizon, it is game over. You will become an official component of the black hole and will contribute to its overall mass for the rest of eternity. But what makes the process of developing a black hole so challenging is getting matter to go beyond the event horizon. How is matter removed from a happy and stable orbit around the black hole and made to fall in, so assisting the black hole in growing to enormous proportions? The fact that there is a limit to the amount of stuff that a black hole can accrete in a given amount of time is another factor that further complicates the situation. If a black hole gets too gluttonous, the universe will basically put it on a diet and make it smaller. This occurs as a result of the fact that the disk of matter that orbits a black hole is traveling and crashing into one another at such an enormous speed that it begins to heat up as a result of the friction. It is heated to such a high degree that it glows like metal in a forge while the process continues. The fact that we can detect black holes and determine their masses thanks to this light is certainly a positive development. The light is able to outshine whole galaxies, and it does so on a regular basis. As a result, they appear to be single pinpricks of light. These pinpricks were initially given the name quasars, which is a combination of the words quasi-stellar, due to the fact that they resemble stars, yet are not actually stars. Astronomers were only able to make out the galaxy of stars that associated with each quasar, and their real significance in producing supermassive black holes was only uncovered until the Hubble Space Telescope was launched in the early 1990s. The light is so strong that it exerts a pressure outwards, called radiation pressure, which prevents any further matter from falling into the black hole. This is the bad news for black holes. When there is an excessive amount of material in the disk, the radiation pressure rises, which in turn drives material farther away from the black hole. There is a delicate equilibrium that exists between the size of the black hole and the amount of stuff that is contained inside its disk. When a specific threshold is reached, which varies depending on the mass of the black hole, the pace at which the black hole may accrete material is limited. In spite of what you might have witnessed in the movies, black holes do not truly suck anything into themselves. For instance, there are stars orbiting the supermassive black hole at the heart of our galaxy, and they will continue to do so without falling in until something else interrupts their orbital pattern and causes them to be thrown off course. In order for something to be consumed by a black hole, it must first fall into the mouth of the hole itself, and the mouth of a black hole, which is what we call the event horizon, is very small. If the entire planet were to collapse into a black hole, the mouth of the resulting entity would be less than an inch across. However, due to the motions of galaxies and stars, there are instances in which matter is sucked into the mouth of a black hole. The supermassive black hole known as Sagittarius A star, which sits at the heart of our galaxy, is mostly fed by the gas and dust that circulate between the stars. We have used telescopes to witness other black holes consuming stars and even gas from adjacent galaxies. These observations were made possible by the existence of black holes. Subscribe now to get the latest ancient history and independent research around the world. There's a possibility that black holes are messy eaters. It is possible for some of the gas and matter to be hurled out at tremendous speeds when objects are being ripped apart. This may sometimes be so powerful that it generates jets and winds that fly off at almost the speed of light, which can have an effect on the galaxy that it is contained within. These jets have the potential to rip apart neighboring stars and planets, or alternatively, they may generate just the right amount of churn to provide the circumstances necessary for the birth of new stars over the course of millions of years. Scientists just found out something interesting about the planets. Watch the next video to know what it is.